Hi everyone, so welcome to chapter 4 video 7. We are going to be doing here now spectator ions, ionic equation spectator ions. So when we're dealing with precipitation reactions only, so this kind of write equations only works with precipitation reactions. So basically if we write out a precipitation reaction, this is one of the easiest things to do in this chapter. So notice that I'm writing the solid only by the, I'm only putting the solid next to the one that's solid. The other ones are all going to be AQ, aqueous. Okay? Aqueous means that it is dissolving in water. When there's an AQ, it means dissolve in water. When there's a liquid, it means it's just a liquid. It doesn't dissolve in water. It is the liquid. Like H2O will always have liquid next to it. So an S next to it means a solid. So what we do is, when all of these are aqueous, they can all be separated into their respective ions. So Pb is 2 plus. Again, we take the 2 here and we bring it up there. Plus NO3 minus. Plus 2NO3 minus, excuse me, because we have 2 of them, plus 2K plus 2I minus. This will give us PbI2. This we cannot separate because it's a solid. Remember, solid, something that is a precipitate, does not dissociate in solution, so it's just going to be PbI2. And then this precipitates into 2 plus 2NO3 minus. Okay, to not get confused, this little 2 down here says that you have 2NO3. This 2 applies to both of them, okay? Only when it's in front of the molecule does it apply to both of them. When it's next to a molecule and small on the side, it only applies to one. So you have Pb2, 2NO3 minus, 2K plus, 2I minus. And then what we do is we're going to cross out whatever is the same on both sides. And then whatever is left over is what is the actual, what's actually happening in the equation. So this is, so these ions that we cross out are called the spectator ions. Okay, so these ions that are on the sides are called spectator ions, which means that they're not really doing anything, they're just there to watch what's happening. And the rest is called, this is called, writing out all of the ions is called the complete ionic equation. The complete ionic equation. The ones that we crossed out are called the spectator ions, and then the ones that are left over is called the net ionic equation. The net ionic equation is what's actually happening, what's actually important to us in this equation. So what they often do is they give us an equation to write out that's not balanced. We first have to balance it before we could write the complete ionic equation and before we write the net ionic equation. So let's do one question together. This happens. Okay. So let's do one whole question together. This is the easiest part from this chapter. Calcium chloride and sodium carbonate. So we have calcium chloride and sodium carbonate. So again, you have to know how to write these out. If you do not know how to write these out, you have to go back to chapter 2. Calcium chloride is just CaCl. Cl is -1, and calcium is always +2, which means we need 2 CCls. So CaCl2, we know that these are both aqueous because they're reacting, they're in the reactant side. Then so is Na, and carbonate is CO3. Carbonate always has a charge of -2, so we need 2 NAs. Okay, I hope by now you are clear on how to write this out. Again, carbonate has a charge of -2, and sodium has a charge of +1 always, so we need 2 of them to balance it out. Now, metathesis reaction happens when they both exchange. So it becomes CaCO3 and NaCl. Now I'm going to check the numbers. So Ca is positive 2 and CO3 is negative 2, so they cross out, so it's fine. We don't have to put any numbers on the bottom. Na is positive 1, Cl is negative 1, so they cross out, it's fine. Again, we don't have to put any numbers on the bottom. So these are our products. Now we need to balance the equation. So the only thing we need to do really is to do the Na, to put a 2 in front of the NaCl, because we have 2 here and 2 here and only 1 and 1 here. The Ca and the CO3 are still balanced. This is easy to do without doing the balancing equations the way I showed you in chapter 3, but if you have a hard time, you can still do it the other way. So now we're going to write the net ionic equation. So first step is writing out the equation, second step is balancing, third step is writing out the net ionic equation. So make sure you're writing this correctly. Ca has a charge of positive 2. You have 2 Cl, the 2 goes to the front, charge minus 1 stays over there. Plus N2 and A plus, because we have 2 of them, and CO3 2 minus. And then we have on the other side, first we have to check which one is the precipitate, because we can't just split them both up. From common knowledge, we know NaCl is always ionic, so we can just split it already and assume that the CaCO3 is the precipitate, but we'll go back just to make sure. CO3 is not soluble except when bound to a few things, but it's not bound to those things, so it is going to be insoluble. So CaCO3 we have to keep together because it's a solid. Then we cross out, we have 2 Na and 2 Cl because we have 2 here. So we crossed out 2 Na, 2 Na, 2 Cl, 2 Cl, and we end up 2 plus CO3 2 minus gives us COCO3, and that is our net ionic equation. So this is finished up with our complete ionic equations, net ionic equations, and spectator ions. Go on to our next video, which will be talking about neutralization reactions, strong acids and weak bases.